So let's get started with our initial Python hands-on, and we will code some of the basic concepts of statistics that we learned in the video session. So let's start Jupyter Notebook. So to start Jupyter Notebook, what I usually do is I move into the directory where I want to work, and here it will be tutorial, and here I'll execute the command Jupyter Notebook. As I mentioned, for Windows user, you need to execute this from the Python from the Anaconda prompt. Okay, so I'll create a new file here, and I'll choose select Python 3 here, and it's ready. So I have the save. So first I will import a few libraries which will help me work on the example. So NumPy. So NumPy is a numerical processing library. It has beautiful functions to help us in matrix operations and linear algebra operations or vector operations. And then I'll also import PyPlot, which helps us in plotting. It's Matplotlib. And we usually give a and for working on notebook in Matplotlib, we need to have this command because if we want to see the output inline. This is not required when you write the normal Python script. You can follow me through your coding, or you can take a pause and follow my instructions. And also I will import the math library. Okay, and I'll press Shift Enter. It will execute this save. Okay, so now let's import the data that we had. Okay, so I'll copy the data from our example of height of soldiers, and here we have the data. Didn't get copied properly. And I'll execute. This actually creates a list variable, and a list variable is starts and ends with a box box bracket, and it has a range of values. So Python, in this way, you can declare a list variable. You can also do like this. It creates an empty list. So we don't need that at the moment. We just can do with the current data. So now we have the data in a variable, in a list variable. We can easily calculate using the NumPy operation mean. We can calculate the mean. But that's the mean. But we want to do it in a bit roundabout way, so that we could learn the different aspects of coding. So what we will do is we will sum these values in a loop and divide it by the count. So count is you can get the count value by, or if it's a list variable, you can call the length operation, len, and pass the variable. So, and you can print the count. This is how you print in Python. And here you see you get the count. Okay, and what for if we want to execute a for loop for okay, let's take the sum in a variable called sum value. The Python convention is to declare variables with underscore data, and we do sum value. So value will get iterate over this list and get each value of the list, and we do some value plus data, and here and at the end we print some value. Oh, I did something wrong. So sorry, it should be value, not data. The value is the list variable. Okay, so press enter. So I have some value. So mean equal to some value divided by count for data, and we can into pattern notebook. If it's the last instruction you want to print, then you don't need to put a print. We'll just show you the mean last instruction of sale, and you see. So now we have seen, we have learned the for loop, and we have learned in numpy operation mean, and we know how to calculate a mean. So we are getting, we will get deeper into Python gradually. Okay then. Now we will calculate standard deviation, and we can do it easily. I have created from here, apart from a code cell, you can create a markdown cell, and I have put the image over here so that we know what the formula of standard deviation is, and we can do p.cd data, the one-step process to find standard deviation. But I'll show you why this is not the standard deviation we will not use. Number one reason, we want to learn Python, and we want to implement this formula, and number two is we can I'll show you after I execute the formula, after I write the formula in detail. So the data, I'll create an array variable out of the data, numpy one-dimensional vector, by using this and converting the data into a numpy array using np.array. It's actually same, but in a different data type now. Okay, let's not print it now. Okay, so what's the advantage? So what I will do is I'll do now. Sorry, it was data. It should be data array. Okay? Now you take like this. Now if I do this, subtract the mean from it. Okay, but mean is a single scalar variable, but that's called Python broadcasting. So Python, when you subtract or when you operate a scalar like a plus or minus on an array, it knows it has to broadcast the scalar into this many variables and subtract it from each of it. So that's a feature of Python called broadcasting. Now I need to square each of the terms. Again, we will use numpy. We cannot use math.square, it acts on scalars, but we will use the numpy library again. Square, and you get the square of each of the variables, and then we want to sum through this, and this time we will not do an iteration, we will just do np. Sorry, I clicked something else. We will do np.sum. Okay, and np.sum can sum across dimensions of an array or a matrix. This is one dimensional, so we do not need to provide axis. You can optionally provide an axis over here if it is multidimensional, like a matrix, like axis you want to sum across axis 0 or axis 1. So here it gives the sum, and then we divide the sum by the count. We had the count variable somewhere, count data. Okay, so count data, and we want to, this is a scalar now, and we can apply math.qrt. Okay, and do it, and here it's exactly same, but this is not the standard deviation we use usually, because we don't get the entire population data, but we usually get a sample of the data. The formula for sample standard deviation is n-1, not n. So what we will do is we will calculate the sample standard deviation. Okay, and we will do -1, put it in a bracket. So this is a more useful standard deviation that we will use. So let's create a method out of it. Get sample std, and it takes the list variable, list data. You don't need to specify the type here, and I return this entire thing, and I change this with list. Okay, I have to do this first. And it converts it into a data array, and I won't have the count here. Let's do again the length of and get the count on the fly. Okay, and we get sample std and pass data. Oh, it's a mistake. Return list data is not defined. List data, I think there's a spelling mistake somewhere. And it's like 80. I execute this cell again. More mistake. I still like it. Oh, so 4.18, you can take it in a variable. std data equal to hope you are following me, or you can take a pause and go through the instructions. So now you know how to calculate the standard deviation. Okay. Okay. Now let's see how to do covariance. So in covariance, we calculate covariance between two sets of data. You remember it was, I think, age and weight of children under 10, and here I have taken the data as a list of tuples. So anything I will see this bracket data is tuples. You can have more than two also here. I could have taken a list of lists also, but that's I wanted to introduce you to tuples also here. So here you see it's 515 is one set, 617 is the second person, second child, 516, 719, and so on. Okay, so here I convert this into matrix first, so that I can leverage the functions of NumPy, and I do that by numpy.np.array, passing this data correlation, and you see we get a matrix here. And then what do we do? Then this is how you can access the rows and columns of a matrix. So dot dot means access all rows for column 0, and this means access all rows for column 1. So the first before the comma counts for row, which is at axis 0, and this is axis 0. These are axis 0s, and this is axis 1. Okay, so this is for axis 1, and you can increase the axis if the dimensions of the matrix increase. Okay, so you can see also you can give range, like ranges from rows 2 to 4. You could give that by 2:4, then comma and 0. That it would mean range 2 to 4, rows 2 to 4 of column 0. So x gives x is so finally x is a vector of age, and y is a vector of weight. And then you can see the next formula here. So x minus np dot mean x. We do element-wise product. It's not the dot product. Dot product is done with using dot. There's an operation called dot. So this is an array, or this is a NumPy array using broadcasting again, and this is another array, and there's an element-wise product, and they are both of this length. So after the element-wise product, we get another array, and we do a numpy.sum on it. Okay, so here you see the formula. So you subtract and then do a summation of it, and I divide by the number of elements. So that is the number of rows which is on axis 0 of this matrix. So data matrix dot shape would return a tuple which is the count of the number of rows and the columns. So it would actually return 1, 2, 3, 4, 5, 6, 7, 8, 9. It would return a tuple 9, 2, and I want to get 9, so I have taken the 0th element of the tuple and n minus 1, so done. And here we get the correlation between x and y. It turns out that there's a function in Python also, in NumPy itself, which can calculate the correlation. It can calculate the correlation, but it returns a matrix. So the matrix is, this is the correlation of x with x. This is correlation of x, y. So you think of x, y here and x, y here. So this is the correlation, not correlation. We did covariance. Sorry. So it's the covariance of x and x, and it's the covariance of y and y, and this is the covariance of x and y, which is same as covariance of y and x. So you can see here it's same. Okay. So that with that we conclude covariance. I would suggest I would suggest you to do the correlation for yourself. Try it out. I will post solution in or you can write, or you can post in the comment, or in other, or not, I will post it in a blog. Okay. Okay, now let's calculate the distance. The distance calculation that I showed in the video was Euclidean distance. So let's see how we can calculate Euclidean distance in Python. So let me take 2 points, and in the example in the slides, I had 2-dimensional points, but here I have taken 4-dimensional points, and I have defined the points as tuples. Again, you could define them as lists also. So these are the coordinates of one of the points in a 4-dimensional space, and these are the coordinates of another point. So it was only x, y in the slide, but it's now 4 dimensions. So each point is represented by 4 dimensions. Okay. So we have to find the Euclidean distance between point 1 and point 2. Okay. So let's see. So here we can see. Here we can see we have to do sum of squares. So I take a sum square as 0, and I iterate over both p and q together. There's a very beautiful operation zip. So it will iterate on both these values. So first p1 and p2 will have 4 and 3, then it will have 5 and 6, and 7 and 5, and 8 and 9. So I do sum square as sum square plus the difference square of the difference. This is how you do a square in Python. And then finally the distance is square root of whatever you get the sum. So you can now calculate the in-dimensional Euclidean distance using this. And let's see, there's an operation in Python also. It's called under another library called SciPy, and it's called distance.Euclidean distance. And you see, we can get it in one step using this operation. So I'll stop the guided hands-on session here, and request you to try out for yourself the similarity and the normalization, the cosine similarity and the normalization. And earlier I mentioned that you need to also try out correlation. Leave your comments, and in the next video we will have a briefing or introduction of linear regression.